Okay, hello students. In the last class we discussed chemical reaction and equation. So in this class we are going to discuss about one more chapter, that is the second chapter of your science, that is acid, base and salts. The chapter nearly consisting of 4 to 5 marks. That chapter we will discuss in this class. Okay, we'll start with acid, bases and salts. So before going to acid, base and salts, first part of the chapter is only acid and base. The second part of the chapter is salts. The chapter is mainly divided into two parts. One is acid, base, second part is salts. So as you studied in your lower classes, the difference between acid and bases. Acids are sour to taste, bases are bitter to taste. That is the lower level. So acids are sour to taste, so bases are bitter to taste. So the food what we are eating, that is acidic in our acidic in nature. So in our day-to-day life, what are the importance of acids, bases and salts? That thing we are going to study in this chapter. So some of the examples for acid is, so hydrochloric acid, HCl, or king of acid, that is sulfuric acid, so H2SO4. These are the two best example for what your acids, and also nitric acid, HNO3. Some of the best example for bases are, so sodium hydroxide, potassium hydroxide and calcium hydroxide. So next we will move on to the chapter begin with, so indicators. What are indicators? Why we will use the indicators means, indicators are the chemical substances. Indicators are the what? Chemical substances that helps to know the which one is acid, which one is base, by showing the change in its physical properties, mainly color or odor. Even in our home, turmeric powder is there. That turmeric powder is also act as a indicator. Here the definition, if the question is arise for 1 mark, define indicator means, indicator is a chemical substance which shows the change in its physical property by mainly by color or odor. Odor means here smell. So there are some indicators what they mentioned in this case. They are litmus paper and one more phenolphthalein. So first one is litmus paper. So litmus paper, there are two types of litmus papers will be there. One is red litmus paper and another one is blue litmus paper. So if we dip that litmus paper, the small litmus paper will be there. If we dip that litmus paper in the neutral solution, there is a pH will be there. There is a pH lies between 0 to 14. 0 to 14. The students, the pH, as you know that one, you already studied in your acid, base and salt chapter. That one, the pH lies between 0 to 14. 0 to 7 is called as acid. 7 to 14 is called as base. So exact 7 is called as what? Neutral. Here, if I dip any litmus paper in the neutral solution, then it is purple. So acidic solution, if I dip that one, the litmus paper turns to what? Red. So if I dip that litmus paper, the small litmus paper, if I dip that one in basic solution, it turns to what? Blue. Then in the same way, litmus is also available in the strips of paper, as I already told that one, red litmus and blue litmus. Acidic moisture turns to. Here one question maybe arises, during the to test the acid or base, the litmus paper motion should be dry. Sorry, litmus paper motion should be wet. The dry litmus paper will not show any change in the color. To show the change in the color, the litmus paper motion should be wet. So then next one indicator is phenolphthalein. So phenolphthalein is also one of the indicator. In the neutral solution it is colorless. So in the acidic solution remain colorless only, but when it is added to the base, then that phenolphthalein will turns that solution into what? Pink in color. So this is all about your what? Indicators. Now the chapter main points I am going to discuss in this one. First, the reaction of acid and bases. The reaction of acid and bases with metal. The first one, reaction of acids and bases. Both acid and bases, how they react with metals. First example, acid, any metal. This is a general reaction. Any acid, not only HCl, any acid react with active metal, it forms salt, hydrogen, and it liberates heat energy. You suppose if I take in the place of acid, if I take HCl, you may take H2SO4, you may take HNO3, whatever it may be, you may take any one acid. If I take HCl, it is an acid react with metal, magnesium. You may take any metal, but for our reaction purpose I have taken magnesium. It is one of the active metal. So reactive or active metal, both are nothing but same. So acid react with magnesium, it forms salt. Here magnesium chloride salt is formed and it liberates hydrogen gas. Along with that hydrogen gas, it liberated heat energy. So any acid, it may arise in your MCQ question. The general reaction, any acid or any base, if they react with metal, any acid or any base, it may react with metal, they always form salt. And they liberates hydrogen gas. Then next one, base. Here the strong base, NaOH, sodium hydroxide is the strong base. If I take this base, it react with zinc metal, then it forms sodium zincate, Na2ZnO2, sodium zincate. It is also an salt. Again, it is also liberated hydrogen and heat energy. So this is the first reaction what they mentioned in your textbook. It may arise for in your examination for 1 or 2 marks. So explain how acid and bases react with metals with 1 or 2 examples. Means you better to write the general reaction is very important. If you know the general reaction, you may generate so many reactions. The acid or bases react with metal, they form salt and water. Then we will move on to the second reaction, that is reaction of the acid, only acid, not base. In the first reaction both acid and bases we have taken. In the second reaction, the reaction of acids with metal carbonate. You may take metal carbonate, means calcium carbonate, magnesium carbonate, aluminum carbonate, like that things you may take. So reaction of the acid with the metal carbonate and bicarbonate. Bicarbonate means HCO3. If I take Na2CO3, that is carbonate. If I take NaHCO3, then it is bicarbonate, sodium carbonate. Na2CO3, sodium bicarbonate, NaHCO3. Here you may take calcium carbonate. So in the place of calcium carbonate, calcium bicarbonate means CaHCO3. Like that things you may take. Here acid react with metal carbonate or metal bicarbonate. They also form salt, water and carbon dioxide. This is a complete general reaction. For this general reaction I have taken one example, that is hydrochloric acid. It react with metal carbonate. Here metal I have selected that one as calcium carbonate. When this acid react with calcium carbonate, that is metal carbonate, it formed salt, CaCl2, calcium chloride salt formed, and along with that one water and carbon dioxide. You may compare first reaction and second reaction. In the first reaction, any acid or base react with metal, they form salt and hydrogen gas. But here there is no liberation of hydrogen gas. When the acid react with metal carbonate or metal hydrogen carbonate, they will not liberate hydrogen gas, they releases water vapor and carbon dioxide. This is the second most important reaction in your acid, base and salts. Then we will move on to the next one, that is neutralization reaction. This question is arised in the previous year. What is meant by neutralization reaction? Means that every day we will go for brush in the morning. So food what we consumed, that is acidic in nature. The paste what we are using, that is base. The acid and base, acid-base reaction, neutralization reaction will be takes place in our mouth. The salt will be producers. The neutralization reaction is defined as the reaction in which acid react with base, it forms salt and water. Is called as what? Neutralization reaction. Tumba simple like baribodu. So acid base jote react adre salt matte water formation madutte anta baradre saku, you will get your 1 marks. So neutralization reaction means, here one more important thing you must should know, metal oxide So obviously metal oxide, they act as base in nature or basic in nature. Metal oxides are basic in nature. Non-metal oxide, for example CO2, C is non-metal oxide, carbon dioxide is non-metal in nature, SO2 is non-metallic in nature. The non-metallic oxides are what? Acidic in nature, but metallic oxide, magnesium oxide, sodium oxide, Na2O, sodium oxide, calcium oxide, these metallic oxides are acidic in they are basic in nature. Metal oxide only react with acid, non-metal oxide only react with base. Why? Because they itself act as acid. Here metal oxide, they itself act as base. That's why first they ask the question, this is the continue part of the neutralization reaction, what they mentioned in your textbook. Neutralization reaction, you may write that example, HCl plus NaOH, it gives NaCl plus H2O. That is a common example what they mentioned in your textbook. That is the continue part is metal oxide and non-metal oxide. When metal oxide is an basic in nature, it react with acid. So when acid react with metal oxide, then it is acid. Metal oxide, as I earlier told, that it acts as a base. So acid react with base, again it forms salt, that is MgSO4. It forms salt and water. So here also you may take then magnesium hydroxide. So here magnesium hydroxide also react with HCl, then it forms magnesium chloride and water vapor. In the same fashion, reaction of the non-metallic oxide means, so this one it react, non-metallic oxide already they are acidic in nature. When they are acidic in nature, they must and should react with base. That's why base, non-metallic oxide, you may write in the place of base, you may write different examples. Base, instead of base you may write metallic oxide also. So here non-metal oxide like CO2 react, then it forms sodium carbonate, Na2CO3 is an salt and it releases water. So this is all about your neutralization reaction. Neutralization reaction mainly consisting of three things. One is what? Neutralization reaction, general neutralization reaction. Second and third one is metal oxide and non-metal oxide. That three reactions are very important for your exam point of view. The next one is dilution. What is meant by dilution? Dilution means diluting. For example, any concentration is more. If while making lemonade juice, if the taste is somewhat sweet means, or too much sweet or means, we will add water. That is also what? Dilution. Here dilution is the process of reducing the concentration of the solution. The concentration of the solution is must and should be reduced, is nothing but what? Dilution, by adding more solvent. While making lemonade juice, ಒಂದು ಶರ್ಬತ್ ಮಾಡುವಾಗ ನಾವೇನ್ ಮಾಡ್ತೀವಿ, ತುಂಬಾ ಸ್ವೀಟ್ ಆಗಿತ್ತು ಅಥವಾ ತುಂಬಾ ಹುಳಿ ಆಗಿತ್ತು ಅಂದ್ರೆ ನೀರು ಆಡ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀವಿ. ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, concentration of that sour taste will be what? Acid, no, what we added for that lemonade juice. So sour taste will be goes on reduces. So the simple definition of the dilution is a process of reducing the concentration of the solution by adding the more solvent. Here for the lemonade juice, solvent is water. Here also we will use, but here for the acid and base, to reduce their concentration, we will add the water. But that reaction is highly exothermic process. Here really it is very highly exothermic process to dilute acid. The most important thing, so in your textbook you already read that one, for the dilute the acid must be added to the water, not other way. So if you take acid, if you pour the water in that one, it is not the correct way. For the water container, we need to add acid. That is also by drop addition. Why? Because it will spills out. So that's why for the dilution of the acid, we have to add the acid to the water container, not acid to water. We have to add acid into the water during dilution process. The next one, strength of the acids and bases. The strength of the acid and bases depend upon the how much H plus ions are present, how much OH minus ions are present. The strength of acid is depend upon H plus ion. The more the H plus ion concentration, the stronger will be the acid. The less the H plus ion concentration, then weaker will be the acid. So base concentration also depend upon that one only. More the OH plus ions, then it will be what? more stronger, basic in nature. So weak acid or weak base contain what? The dissociation. Here the most important word will be there, that is dissociation. Dissociation means so breaking down of the molecule, or splitting of the molecule. If it dissociation completed, then it is strong acid. If the dissociation is not completed or partial, if dissociation not at all takes place, means then it is not an acid or base. If dissociation is completely occurs, then it is strong acid. If the dissociation is partial means half, then it is weak acid. If the dissociation is not at all takes place, then it is not an acid or base. So we'll move on to the next slide. In that next slide, what they mentioned is universal indicator. In the universal indicator, it is nothing but pH. pH is called as a universal indicator. So in your higher classes, when you go to first PUC, if you select the science, you will learn about pH. For that one value is there, negative logarithm something. So pH is the universal indicator by changing the color. As I earlier told that in the beginning of the class, that is 1 to 14 or 0 to 14 indication of the water pH scale. You may observe by changing these types of different colors, that will indicate the what? Acid or base, how much stronger. So 7 is indication with green, that is what? 7 is neutral in nature. The coconut what we are drinking, that is neutral. The distilled water what we are using in our day-to-day life, that is also neutral. The food what we are consuming, that is acidic in nature. So if you go from 7 to 1, then it will become stronger and stronger acid. The pH 1 is very strong acid. If you go like this, the acidic nature will be decreases. If you come from 7 to 1, then the acidic nature goes on increases. Acidic nature is nothing but, as I earlier told, that H plus ion concentration, or else you may call that one as hydronium ion concentration, that is H3O plus hydronium ion concentration. When we move from 7 to 14, the basic nature will be goes on increases. If we move from 7 to 14, the basic nature of that will be goes on increases. That is also one of the point you need to learn in this pH. pH is called as a universal indicator. Next we will move on to the importance of pH. So you are saying that pH is one of the important thing in our every day-to-day life, means there are 5 different examples what they mentioned in your textbook. They may arise for in your examination for 2 marks. Write the importance of pH in your everyday life or day-to-day life anta question bantu antandre, you have to select. They may ask the question. So first, pH sensitive of the plants and animals. So plants and animals are sensitive to pH. Crucial life process such as digestion of the food, function of enzymes and hormones happens at the certain pH value. So in our stomach there is a gastric juice is present, that is HCl. The gastric juice is present in our stomach, that is hydrochloric acid. The dilute hydrochloric acid is present in our stomach. That is also one of the main thing to maintain its pH. So if you not maintain the pH, we are also entire body to function any one thing in our, to function any one gland, function any one organs in our body, they required suitable pH. Like that for the plant also. For the plant will not grow for any other pH. For the growth of the plant also they required suitable pH. So the next one, pH of the soil. So pH of the soil optimal for the growth of the plant crops is 6.5 to 7. The pH slight acidic motion should be there. 7, I already told that the 7 is neutral. So to grow plants very well, so the pH motion should be slight acidic, that is 6.5 to 7.0. In this condition the plants will grow very well. That pH of the soil optimal for the growth of the plants or crop is 6.5 to 7. If acid rain over, so if the acid rain over, the pH become less than 6.5 or 6 or 5.6, like that over means, then the pH of the soil will be loses towards or it go towards acidic nature, then the plants can't grow well. So then third most important, pH pH in the digestive system. As I earlier told that the process of the digestion happens at the specific pH in our stomach, which is 1.5 to 4, which is not mentioned in your textbook. 1.5 to 4. At that pH only, that what happens, specific pH in our digestion process will be takes place. Above that one, it will be not takes place. Below 1.5 also not at all takes place. The pH of the interaction of the enzymes while the food is being digested is influenced by the HCl in our stomach. As you know that in the life process chapter you studied, that is in our stomach it contains 2 enzymes. So pepsin also present in our what? Pepsin, and the layer, entire layer is stomach layer is covered with mucus. The pepsin, it is produced in the stomach. For the action of pepsin, the pH motion should be what? 1.5 to 4. So here to overcome this pH, if the too much acidity over means, to overcome that acidity we will use antacids. We will use what? Antacid. Antacid will be that is completely basic in nature, that will cure the water acidity of the stomach. So these are the 3 important uses. Still 2 more uses are there, that is pH in our tooth decay. So tooth decay happens when the teeth are exposed to the acidic environment of pH 5.5 or below 5.5. So students, here after the pH below 5.5 or if it is 5.5, so then that condition, some of the bacteria will get activated in our mouth. Below 5.5 pH, the some of the bacteria will get activated. So when the some of the bacteria will get activated, they start to what? Decay of our tooth. The tooth decay will be takes place. They will break down the glucose molecule. At that below 5.5 pH, the glucose molecule, the food left in our teeth, during night time, if you consume food, after consuming that food, if you not wash our mouth properly, then some of the food remain in the teeth. Below 5.5 pH, some of the bacteria will get activated. They will break down the glucose molecule. They releases some amount of acids. That acid is reason for the tooth decay. So then 5th one is pH of the self-defense by the animal and plants. There are 2 or 3 plants and animals which will be self-defense will be there. So for example, ant contain methanoic acid. The ant, what they are? So if the ant will be bite, actually our entire body pH is neutral. 7 will be there. Entire body pH will be neutral. When our body pH is 7 or neutral, any acidic, if that any ant bite over any ant bite over, then it releases methanoic acid that causes irritation. Why means acidic nature over, our body is completely neutral, but that over what? Acidic. So acidic substances are used in the animal and plant as a self-defense mechanism. For example, bee ant, that is honeybee in their ant sting, that contain formic acid. Formic acid is nothing but methanoic acid only. So plants like nettle secretes a highly acidic substance for the self-defense. So here nettle plant also contain what? A highly acidic substance for their self-defense. There are the best example. B, you may write for the plant nettle. Then these secreted acid substances have the specific pH. So we will move on to the next slide. That is, students, you must should know in that chapter, in that entire thing, the everyday uses of pH are pH in our day-to-day life, or explain pH in our day-to-day life. 2 marks question arise means at least you have to write any 2. If specifically explain the role of pH in our tooth decay means you have to write only for tooth decay. So next, second part of the chapter, that is what? Salt. So what is our common salt in our day-to-day life? What we are using means that is NaCl, that is called as a common salt for the food what we are consuming in our day-to-day life. Before going to that one, what is salt? Salt is a combination of one cation and anion. ಒಂದು ಪಾಸಿಟಿವ್ ಒಂದು ನೆಗೆಟಿವ್. ಸೊ ಪಾಸಿಟಿವ್ ಯಾವುದಾಗುತ್ತೆ? ಮೆಟಲ್ ಆಗುತ್ತೆ. ನೆಗೆಟಿವ್ ಯಾವುದಾಗುತ್ತೆ? ನಾನ್ ಮೆಟಲ್ ಆಗುತ್ತೆ. ಸೊ ಕಾಂಬಿನೇಷನ್ ಆಫ್ anion of an acid and cation of base. Na plus, that is metal. Cl minus is what? Negative. Cl minus is non-metal. Here combination of anion of acid and cation of base is called as what? Salt. For example, potassium chloride, sodium nitrate, NaNO3 and CaSO4 etc. are the best examples for salt. Salts are usually prepared by the neutralization reaction of the acid and base. Why? Because during neutralization reaction, NaOH acid react with base, it formed salt and water. By the neutralization reaction only we will always form what? Salts. Then common salt is sodium chloride, referred as a common salt because it used over a worldwide for cooking. Why it is called as common salt means for cooking we will use, that's why it is called as common salt. There are three types of salts are there in your textbook also they mentioned, that is acidic salt, basic salt and neutral salt. You know how they formed already, you studied in your school, so one more time I will recall that things. So a salt of strong acid and strong base will be neutral in nature. If the strong acid NaOH react with HCl, it is an strong acid, HCl is a strong acid, NaOH is a strong base. When the strong acid react with the strong base, then the salt what they form, however you studied neutralization reaction, acid react with base, that forms salt. Then strong acid react with the strong base, then definitely it form what? Neutral salt. Its pH approximately 7. Then students, you came to know that the salt what we are eating in our day-to-day life, that is neutral in nature. If the weak or basic salt means weak acid, any weak acid, for example acetic acid CH3COOH, acetic acid react with strong base like NaOH, then the salt is formed is basic in nature. Weak acid, strong base, then base strong is there, then basic salt. Then last one is acidic salt. During formation of the acidic salt, the strong acid motion should be there and weak base, then the salt formed is acidic in nature. So strong acid, strong base, neutral salt, strong base, weak acid, strong base is there, weak acid is there, then it is basic salt. Strong acid, weak base, then it is acidic. Which one will be strong? That will be the nature of the salt, but both are strong, then it will be neutral. Then we will move on to the next slide. In that next slide, so students, here there are 5 things are there: preparation of NaOH, preparation of baking soda, preparation of bleaching powder, preparation of one more thing is there, the washing soda, then POP. These 5 important things. Among these 5, one will be in your examination definitely, along with the reaction, balanced chemical reaction you need to write, and also you must should know the users. You must should know the what? Users. First we will start with the preparation of sodium hydroxide. Preparation of water, sodium hydroxide. How sodium hydroxide is prepared? So chemical formula of sodium hydroxide is NaOH. Its general name is caustic soda. Preparation is by chlor-alkali process. By the chlor-alkali process the preparation will be takes place. That is also called as electrolysis of brine. What is meant by brine means, simple definition of the brine is salt, NaCl along with water, NaCl along with water, that is called as water. Brine solution. At anode Cl2 will be released, at cathode H2 will be released. In the next slide I will explain how the preparation of that NaOH will be takes place. So with the help of diagram I will explain. So brine, as I earlier told that brine is a mixture of salt and water, NaCl along with water. If you pass brine solution into this container, the container already contain 2 electrodes. So one is connected to positive, another connected to negative. So positive end and another one is negative end. So when you pass that one into the brine solution NaCl along with water, if you pass that one into the container, then by passing electricity, if they ask the question for preparation of NaOH, then for the brine solution by passing electric current we will get NaOH. We will get what? NaOH. NaOH formation will be takes place. Brine containing sodium hydroxide. Each product, what the 3 products are formed during this chlor-alkali process. The 3 products are formed. 3 products are having different users. NaOH also having different users, hydrogen gas also having different users, and chlorine gas also having different gases. That one, so hydrogen gas may be used as fuel, chlorine gas may be used as bleaching powder. So NaOH is also having different types of users. So Now brine, by passing brine solution into the container, by passing strong electric current, it forms the NaOH. If you write this much, you will get your marks. So, and also it formed chlorine gases, and it also releases hydrogen gas. This is all about your water. How the NaOH is formed. We will move on to the next one. The second thing is bleaching powder. How bleaching powder is formed? Bleaching powder is, the chemical formula of bleaching powder is CaOCl2, or you may write that one as CaOCl2. You better to write CaO, calcium oxychloride. We call that one as calcium oxychloride. In textbook they mentioned, here not is there. So bleaching powder, the common name of this one is bleaching powder. We call that one as calcium oxychloride. How this one is formed means, for calcium hydroxide, the aqueous calcium hydroxide, if I pass chlorine gas, for the calcium hydroxide, aqueous calcium hydroxide, if I pass chlorine gas, then the product formed is calcium oxychloride, and also it releases water. But our product is this one. So students, you must and should write balanced chemical reaction. Calcium hydroxide, CaOH twice, react with the Cl2. It forms CaOCl2. That is also aqueous in nature, plus it releases water. Then what are the uses of this bleaching powder? Means so many uses are there. It is used in swimming pool. It is used in as to clean the what? Bleaching powder, to release the chlorine, which is responsible for the bleaching action. So in our day-to-day life, so what we are using bleaching powder, that is CaOCl2. But in this one, which one is causes more action means Cl2 is the main responsible for cleaning. If the Cl2 is present, then only the cleanliness will be there. So that's why bleaching powder releases chlorine gas, which is the responsible for bleaching action. So we'll move on to the next one, that is baking soda. Baking soda, it is also used in our domestic purpose, in our home and bakeries we will use that one. So which one? Baking soda. Baking soda is prepared from solve process. That is the general name of that baking soda chemical name is sodium hydrogen carbonate, or sodium bicarbonate, NaHCO3. So limestone is heated. If I heat this limestone, CaCO3, then it forms quick lime. That is nothing but calcium oxide. The another name of calcium oxide is quick lime. Along with that one, it releases carbon dioxide. So CO2 is passed through the concentrated solution of the sodium chloride. So here sodium chloride is there. So you have to write the balanced chemical equation. So how the baking soda is prepared means, baking soda is prepared by, for the salt, aqueous salt, we have to pass ammonium gas, and we have to pass ammonium gas, we have to pass ammonium gas, and also we have to pass that CO2. First in a test tube, we have to take salt, then we have to add water. We got brine solution. So that is nothing but aqueous solution of sodium chloride. For that aqueous solution of chloride, we have to pass ammonium gas. Then later, if I pass carbon dioxide, the product formed is sodium bicarbonate. Along with that term, ammonium chloride is formed. But our intention, we are going to prepare sodium bicarbonate, that is baking powder. The simple reaction, NaCl plus H2O. You already know that one in the preparation of NaOH. NaCl plus H2O, then ammonia, NH3, by passing carbon dioxide into that test tube, we will get our product NaHCO3. Then uses of this baking soda, it is used in textile industry. Here NaOH is also used in textile industry, but before that one, the baking powder is also used in textile industry, paper industry, and disinfectant. It is also used as what? Disinfectant. Then next preparation is washing soda. Washing soda chemical formula is Na2CO3. Washing soda chemical formula is Na2CO3. Na2CO3. We'll move on to the next one. So washing soda chemical formula is Na2CO3. So Na2CO3, for that sodium carbonate, by recrystallization process, by adding 10 molecule of water, by adding 10 molecule of water for Na2CO3 by recrystallization process, plus 10 molecule of water, it forms Na2CO3. You have to put dot, then you have to write 10H2O, that is hydrated one. It contain water molecule. So this so washing soda is also have a lot of application in our day-to-day life. So then we will move on to the next one, plaster of Paris. Plaster of Paris, that is POP, you call that one as, generally call that one as POP. How the POP is formed means, for the calcium sulfate 2H2O, calcium sulfate 2H2O, it is called as what? Gypsum salt. We call this one as CaSO4 dot 2H2O, that is called as what? Gypsum salt. For the gypsum salt, if I heated that one around 373 Kelvin, here the reaction is not mentioned, so CaSO4 2H2O, if we heat this one, put arrow mark, if we heat this one around 373 Kelvin, then that one loses 1.5 molecule of water. Here 2 molecule of water there. If we lose 1.5 water molecule, only half water molecule left, then the product what it is formed, CaSO4, after heating to 373 Kelvin, the product formed is half H2O, that is CaSO4 half H2O. Then this one is called as what? Gypsum salt. Sorry, from the gypsum salt we got what? POP. From the gypsum salt we got POP. So POP have a lot of application in our day-to-day life, like making the statues, the Ganesha statues, what we are making the toys. In that case also there are some uses are there. Then for the cost for the healing of the fracture, if the any bone fracture over means, then also they will use what? POP, plaster of Paris. Students, this completes the chapter of your acid, base and salts. In this chapter, especially in the salt part, you have to be preparation of NaOH along with uses, and also second one is baking soda along with uses. The next one is washing soda reaction uses, then bleaching powder reaction uses, then last one is POP, how to prepare POP and uses of POP. These things you must and should be know in this chapter. So thank you for